We started Planetary Resources because we felt that it was the right time to really try to develop the capability to bring the resources of the solar system into our economic sphere of influence. We sit here at the beginning of the 21st century, and everybody knows that the planet and its resources are becoming more and more constrained. And for the last, since man was able to see the stars, we've been looking up and hoping that we could go there one day, not just to visit, but to stay. And in order for us to really have millions of people living in the solar system in places other than Earth, we have to be able to harness the resources of space. So Planetary Resources' vision and goal is nothing less than enabling the resources of space to be accessible to humanity.
In the short term, do you feel that your guys' plans of mining some of the rare earth metals is going to lower the market here on Earth, or would those materials not be returned to Earth?
Well, I think in the early stages of the company, we'll be very focused on setting up orbital propellant and fuel depots. So we want to essentially create the gas stations of the inner solar system so that if you're flying a mission into deep space, you don't have to bring all the fuel with you that takes up space that payload could be using. And so we found that by enabling this network of fuel depots, that we can actually have a payload amplification factor of somewhere between 10 and 20, which would drop the cost per kilogram by a similar amount, assuming no other changes in technology.
And that would be mostly, you'd be getting the resources from that from the carbonaceous asteroids in the water?
So about half of the asteroids are carbonaceous chondrites, somewhere in that range. And the carbonaceous asteroids are very, very applicable to mining for fuel because they're between 10 and 20% volatiles, including water, other types of ices, carbonaceous, of course, from the name, nitrogens. You can even get ammonia on them. And the idea would be to break down those materials into their base constituents and use them for propellant. Now, once we've got the propellant depots set up around the solar system, the inner solar system, that's when we can begin to economically bring back materials to the surface of the Earth. Be they the platinum group metals, other rare and precious materials, and that's when you'll see a big push to include the resources from space into our budget of resource consumption and usage on Earth.
Are there any sort of plans to use any of these resources, keep them in space, and do high technology production in space using these metals as superconductors and things of that nature?
Well, eventually that would certainly be the goal. To in situ manufacturing and production of materials is, of course, part of the big picture of space development. I think our part will be to make sure those raw materials are available in there. We're not going to be, at least I don't currently foresee us getting into the manufacturing business and refining developing those raw materials into actual products. I think that's somebody else's job.
So from my understanding, you guys are pretty far along in the development of the Arcid 100 series. And what are some of the other applications other than searching for asteroids that you would be using this space telescope for? So
that's a great question. The Arcid 100 series is a high-performance, low-cost, easy-to-use observation platform. And so, quite frankly, it could be used to look back at the Earth, and there are hundreds of applications of Earth observation that I don't need to go into. It could be used for deep space astronomy. It could be used to analyze and survey satellites that are in space. Pretty much anything that you'd want to look at, either on the ground or in space, the observer, the Arcid 100 series, can look at. And depending on the size of the optic we use, you're talking about sub-arcsecond resolution. So it could get significantly less than that, depending on how big of an optic we use, and will be a very powerful observation platform.
Will it only be able to image in the visible light spectra, or will it also go into infrared and other? So
we're not. I mean, the optic that we're nominally looking at now is a visual range wavelength detection device, but there's no reason that we couldn't put infrared, ultraviolet, or other types of detectors on different spacecraft in the constellation, so that we could get a hyperspectral picture of a certain object. Obviously, infrared is very important for gauging temperatures. There's a lot of reasons why you would want other kinds of sensors other than just optical detectors.